So hello everyone and welcome to this next lecture. So in the previous lecture we were talking about Numpy arrays, and in this lecture I'll continue a little more about Numpy arrays. Mainly in this lecture I will continue with some of the more advanced functionalities of Numpy. So before I get started, it's almost 3 p.m. Just a quick question: does anyone have any doubts or comments from the last lecture? Well, since there are none, I will get started soon. Just wait for another minute. So it's 3 p.m. and I will get started. So as before, just a little quick request to all those. Please put yourself on mute until it's time to really do a little bit of Q&A. So to get started, as always, since I launched my Jupyter Notebook again, I will have to run this command, import numpy as np. So what we're going to do is we're going to look at first numpy functions, right? So for example, we looked at a few functions like square root. So I'll just continue with that. So let me just create an array. So this is a single dimensional array. Actually, I should probably change this to 10 because I want to convert this to a 3 by 3. Okay, this is it. Now, what I'm going to do is I'm going to convert this to a 3 by 3 matrix. This is what I have. Now, the question is, what can we do with respect to functions on arrays? So like, for example, we can even do exactly what we did before. That is, we can do np.square root. And you will see in this case, it is applying the square root function to every element of the array, right? You can actually verify it yourself. Any function that you apply, okay, any function that you apply to a matrix, if you do not specify any other arguments, is applied to every element of the array. So now the question is, are there any other options? And the answer is yes, there are. So for example, if you look at the square root functionality, let's look at the arguments. In almost every kind of argument, you'll see that many of these functions have some additional kind of castings. So for example, some of these, right? Now, here with square root, there isn't much, but let me try out another one. Let me say np.sum array1. And you'll see this one has actually taken the sum of every element, right? And it hasn't discriminated between the rows or columns. It has just taken the sum of everything. Now, let me go and look into the help of this. And here you'll see there is another argument called access. The default value is none, right? But access can have a value. Access can have different values, which means these values correspond to whether it's a row or a column. So let me just give a few examples. Supposing I say access is equal to 0. What this means is you are saying perform the sum along rows, right? So let's do it and see what result we get. Oh, sorry. You got to specify the array. You can't just do that. Now, if you compare what's happening, you'll see it has actually taken the sum of every column, right? Look at this. 12 is 1 plus 4 plus 7. 15, 2 plus 5 plus 8. 18, 3 plus 6 plus 9. When you say access equal to 0, you are instructing NumPy to perform this function, right, which is sum on this array, but along the rows. What that means is take the sum of every column, right? So at this point of time, I'll just stop and ask, does anyone have any doubt? I'm pretty sure somebody will. Nobody has a doubt? Anyway, so the way this can actually be useful is, particularly when you have multi-dimensional arrays, we can try out different kind of sums. So we can apply the function to every dimension. So for example, here we have a two-dimension matrix, which means we have two axes, 0 and 1. 0 stands for the rows, 1 stands for the columns. So when you specify 0, you are applying the function along the first dimension, right? Which means the first dimension increments, the 0th dimension. 0th dimension means row. When you specify axis is equal to 1, it is the first dimension which is incrementing, and the first dimension is the column. So which means now it will be taking the sum of every row. So let's try this out. And you see, this is exactly the result. Compare the result. It is 1 plus 2 plus 3, 6, 4 plus 5 plus 6, 15, 7 plus 8 plus 9, 24. You can verify the result yourself. So this way you can apply in some functions when you're taking things like sum, mean is another one. The only way to figure out is if this happens is to check the help. Some functions do have this option, some functions do not have this option, right? So again, I'll just stop for a minute. Does anyone have any doubt about what I did? I just want a little confirmation. Is everyone able to hear me okay?
Yes, we're able to hear
Okay.
you.
Okay, so that's it.
Yes, sir.
Okay, fine. So anyway, I will continue for now. So there are a number of functions which you can apply with respect to NumPy. And I would say you can just go over to the website and check. But for now, I will just keep going because the idea is to just give you a little bit of an introduction. As we continue, we can look at more details, particularly when we get into data sets.
There is a question in the chat.
Okay, so now my suggestion is, actually, I did notice when you have a doubt, please do ask the doubt rather than put it in the chat, because I don't usually look at the chat. Can someone just ask that question to me, please?
What is the use of the axis function? That's what is the question in the chat.
So the axis, like I said, when you have a two-dimensional array, so you have here a two-dimensional array, right? Which means a two-dimensional array in NumPy terms is seen as a multi-axis array, right? Now, a multi-axis array means here, like we know it as humans, we know it as two dimensions. The first dimension is the row, the second dimension is the column. Now, NumPy sees it as axis 0 is the rows, axis 1 is the column. So here, like for example, the sum, you are always summing up the elements of an array. If you don't specify the sum, let me try mean instead. If I say mean of array 1, it'll take the mean of all the elements. So basically it'll sum all of them, right? All of them, no discrimination between rows and columns, and it'll divide it by 9, right? That's what it does by the total length of the array, with the total number of elements in the array. Now the problem is, what if you don't want this? What if you want to find out the mean of all the rows, right? So what if you want to find out the mean of the first row, second row, third row? Now, in that case, you cannot directly just say array 1, right? You have to tell NumPy, apply this function along one axis, along one dimension. So as I said, the axis 0 is rows. So if you say axis is equal to zeros, only the rows will increment when the function applies. When you say axis is equal to 1, the columns will increment as the function applies. So if I want to find out the mean of every row, it means you want the column to increment. So you have to say axis is equal to 1. So then I just say np.mean array1 axis is equal to 1. And I now get the mean of all the rows. So you can verify this yourself. 2 plus 3 plus 3, 6 divided by 3, 2, right? So you can verify this yourself. So this way, in multi-dimension, sometimes you may have more than 2. You may have 3 dimensions, 4 dimensions. In that case, you can use this axis method to calculate a function, or rather apply a function along a certain dimension. So does that answer the question?
Yeah, that's clear.
Okay. Okay, so now there are many functions, right? So for example, all you have to do if you want to check, just do tab and just see everything. So you have a huge number of functions that you can apply: cosine, sine, trigonometric, you name it. It's like it's this Numpy is one of the most extensive collection of mathematical functions that you can apply on scalars and also on arrays, right? So I would say the best way to do, if you want to know more, is just take a function, just do shift tab and you'll know more, right? So according to your application, I would say go ahead and check out those that you need to, right? For now, I will continue to the next topic, which is NumPy array extractions. So before I continue, is there any other doubt that you would like to ask about just functions? Like for example, anyone wants a particular function that you want to look at? Okay, so
Hello, sir.
I'll continue. Yeah, okay, I'll continue for now.
Uh,
Okay, yeah, go ahead.
Sir, how can I change a single element of the matrix? Means if I want to apply some math on that particular element of that matrix, how can
Yeah,
I do that?
yeah, that is what is coming up next. So what I'm going to do next is talk about array extractions. So the first thing which I'm going to do is let me just take a slightly bigger array. So let me say np.arange, let's say 1 to 36. Let me just verify I got the array. Yes, it is. And let me just reshape it as 5 by 7. So I have this array, right? Which is basically, it has 5 rows and 7 columns. So now the first question like you asked is, what if I want to extract a certain element? Now, it is quite similar to lists, only slightly different. So for example, let's say I say always indexing starts at 0. So if I say 0, I extract the first row, right? If you see, you can verify it is the first row. So in the same way, you can extract the first column, or rather, you can extract the second column with index 1, and this goes up till 4. Okay, and just like in lists, Python lists, if you try to extract something that doesn't exist, you get an out of bounds error, right? Now, this also will work just like Python lists. Like I said, in Python lists, you can use a negative index to go backwards. That is, you can start traversing your list backwards. So we can say -1, -2, so on and so forth. Now, supposing I want to extract, let's say I want to extract this element, or let's say I want to extract 17, right? So the first thing you need to see is which is the index of the row. So this is the 0th row, this is the first row, this is the second row. So I can extract this as the second row. Now, depending on the background you come from, some of us will come from backgrounds like C or C++, Java, you would be used to putting another square bracket and extracting the index. So this index is again column 0, column 1, column 2. So you would do this, right? Oh, sorry, put it wrong. This is a typo. Yeah, so then you get 17. Now, there's nothing wrong with this, but with NumPy, do not do this. The reason is When you do this, you are extracting one row from this array, all right? And from this row, you are now extracting an element. Again, sorry, making a mistake here. Yeah, you are extracting an element. The problem is that in Numpy, this is a double operation. The better way to do this is with just using comma. You get exactly the same thing. This extracts an element with just one operation. So in Numpy, use this method rather than this method. This is much faster. And this makes a difference when you have large arrays, let's say with 1,000 elements or 100,000 elements, million elements. Always use something like this, because then you're extracting it with just one operation. So I'll just stop for a minute. Does anyone have any doubt?
So math operation on this is straightforward
Oh yeah,
on the
like,
element.
yeah, like for example, I can just do some square root 2. I mean, you can apply, if you want, you can just apply the whole thing. So it's okay, because NumPy square root 2 will take either a scalar or will take a vector, or there may be some other way. Like for example, you can say square t2 array 2. Let's do shift tab. And there may be a way in which you can actually, I don't know if it's x array like. So there may be, actually you might have to Google it, but there may be a way in which you can actually apply it to a particular element. Let me try this and see. No, there isn't. So there might be, I probably got the element, I probably got the usage wrong. So there may be some way of you can apply this method square root on just one element. But the simplest way to do it is using this. You can just apply your function on this.
Okay, thank you.
Yeah. Any other doubt? So the next thing I'll talk about is what is called as extraction. So just like in Python lists, even in NumPy arrays, you can extract slices of the array. So for example, let's say I take the same array. Let me just write it again because I have to scroll up. So this is it. Now, supposing I want to extract the first 2 rows, right? The entire first 2 rows. In that case, I could do something like :2, right? Now, just like in Python lists, right? We remember when we see, let's say list 1 is equal to list range 5. And we saw that list 1 gives us this. In both lists and in NumPy arrays, you can use the slicing method, right? So for example, if I want to specify, for example, more than one element to extract, I can use the colon method. So for example, what this means is, I'll just put the syntax first. You have to specify array name, square bracket, start, colon, stop. Let me put stop plus 1, and you can say start, colon, stop plus 1. So what this means is you can specify a row starting point and a row stopping point, and a column starting point and a column stopping point, right? Now, if you omit any of them, if you omit the start, it becomes 0. So here I omitted the start, so it became 0. The stop is stop plus 1, so it's 1 plus 1, which means the stop is 1. So it will stop at the first row. So what this means is it will give you the 0th row and the first row. Now this is a little tricky, so I'll do a few examples to make it a little easier to understand. So let's say, for example, I want to extract the first row and the second row as before. One way to do this is I could specify 1, 2. Okay. Let's say, for example, From this, I want to extract again the first two columns. I could again to this give another specification saying 0, 1, right? So actually there was a slight mistake. This should also have been 0, 1 and 0, 1. So now if you go back and see, I have actually extracted the first two rows of the first two, or what do you call it? I have extracted the first two rows, and from the first two rows, I have extracted the first column and the 0th column and the first column. That's why I get 1 and 9, right? Now, this is one particular way of extraction. Now here I'll ask a question. I know this is a little tricky. So does anyone have any doubt here?
I have a bit confusion. Are we using Numpy or normal Python functions here?
See, it's like this. You can use normal functions as well. So for example, when you're talking about functions, are you talking about extraction or are you talking about?
Yeah. This part we did using the Numpy library or just normal math library?
No, here when you look at array 2, it is a NumPy array,
Okay.
right? If you look at list 1, it is a Python list, right? The reason why I wanted to show you this is that a lot of these functionalities can also be done with list. This comes from basic list manipulations as well, right? So
Okay.
for example, even in list 1, I can specify, let's say I want 2 and 3, right? I want these two elements. This is the 0th element, this is the first element, this is the second element. So I can extract this as saying 2 colon 4, and I get exactly the same result. So it starts, this is the start index, and this is the stop index plus 1. That's how you see it. The same thing can also be applied to arrays as well, NumPy arrays. So for example, if I say array 2, if I say I want to extract the first, let's say I want to extract these 3 rows, right? So what that means is this is row 0, this is row 1, this is row 2, this is row 3. So if I want row 1 to row 3, I have to specify my start as 1 and my stop as 4, right? Always it is stop plus 1. So I can say array 2 1 colon 4, and I get these 3. All right. So this is how you can extract a bunch of rows. Now, in addition to this, you can also extract within this columns. So for example, let's say I want to extract the first, let's say the first 3 columns. Let's say I want to extract 8, 9, 10, these first 3 columns. I would just say colon 3, and I get this. So you can extract sub-matrices or sub-arrays from a NumPy array using this slicing. Again, what I would say is, tell me some examples of what you would like to do, and let's do it together. That would be more interesting than me just giving some examples on my own.
Can we go even further? Like, can I get 16, 17, 23, 24 matrix, that square matrix?
You want, okay,
no, in
okay.
row 46, output
46, okay, yeah.
Can I get the 16, 17, 23, 24, that square matrix as well?
Yes. See, main thing you need to understand is when this result, it says array, right? This means this itself is an array. Okay. So you can have another set of indexing to this as well. What is most important is whenever you see the output of something, check what kind of object it is. It is an array, right?
Okay.
So it is a NumPy array. So you can do exactly. So let's say what this means is for this array, 16, 17 is row 1. This is row 0. This is row 1. This is row 2. At the same time, 1623 is column 1 and this is column 2. So what this means is we need to say 1 colon and 1 colon, and you get that.
Okay, got it. Thanks.
Sure. Any other question? We can do maybe a couple of more examples.
Excuse me.
Yep.
Can you please scroll down a little bit?
Yeah, sure.
In row 47, it's like the same thing that you mentioned.
Mhm.
It's first selecting an array and then you are reselecting from that.
Yeah.
Can we not do it like, in way where we do it in a single go rather than
Oh yeah,
selection after selection?
sure. So what basically he wanted was this one, this little block, right? 16, 17, 23, 24.
Yeah.
So again, just calculate what you need. From array 2, this is row 0, row 1, row 2. This is row 3, row 4. So basically we are going to stop before row 4. So let's write that down. So array 2 and again 0, 1, 2. So 2 to 4. This is our row. This is our rows. Now here columns. This is column 1. This is column 0. This is column 1. This is column 2. So we start at 1 and we specify 3 because we will stop at 2, right? So this is 1 colon 3 and we get the same result. So I hope that's clear. You just basically have to start counting. First find out which row you want to start at, right? So this is row 0, row 1 and row 2. So this is your starting. Now you got to figure out where you want to stop. You want to stop at row 3. If you want to stop at row 3, the stop you must specify is always 1 greater than what you want. So you want to stop at 3, you must specify 4, right? Similarly, the column is 0 and 1. So it starts at 1. So our starting will be 1. But you want to stop at 2. So that's why the stop element must always be specified as 3, 1 greater than where you want to stop. So does it answer your question?
Yep. Thank you.
So any other little doubt? I can just talk about, otherwise I'll just talk about a couple of other functions with respect to Numpy before we can actually wind this up. Okay, so I'll just continue for now. So let me just, in this, I can maybe extract, since we've been talking about this, let me just extract colon 3, colon 3. Let me extract the first 3 rows and the first 3 columns. Typo. So this is what we get, right? Just a 3 by 3 matrix. Now, let me create another matrix, NPI3. And this is an identity matrix. Now, in NumPy, you can perform operations between arrays, like you can perform mathematical operations. Now, since most of us come from an engineering science background, from our definition, when we do summation multiplication, there is a certain way we do it. However, NumPy sometimes does it in a slightly unexpected manner. So I'll just show you what that is. Supposing I want to add these two matrices, that is array 3 plus array 4. This is as expected, right? Because when we sum, okay, I'm about to run out of time apparently. So another 10 minutes, I'll wind out soon. So when we sum two arrays, the summation is always performed element by element. And that's what happens here. You can verify it yourself, right? Now, at the same time, you can also perform subtraction. So you can do array 3 minus array 4. And this is also element by element, because remember, summation and subtraction are always element by element. The problem comes when you do multiplication. So let me do multiplication. Now, if I say array 3 into array 4, what do you expect, right? One is an identity matrix and one is this matrix we just created. So a little guess here. What would you think will be the result?
Would it be element-wise multiplication?
Exactly. So this is what it is. It has just multiplied every element by element. Actually speaking, if you multiply this, any array by an identity matrix, you get back the matrix, right? That's what we know from basic mathematics. But in Numpy, if you specify just the multiplication, it does an element by element multiplication. That doesn't mean you do not have that functionality. For example, let's say I want to do proper multiplication. In that case, you use something called as the dot function. So you just look into it, it'll say the dot product of two arrays, right? And dot product is the way we know array multiplication to happen. So for example, if I say array 3 multiplied by array 4 and I check array 8, I get back the array. So remember, sometimes this is a little confusing. If you are using NumPy arrays and you want to actually perform array multiplication, don't use the multiplication operator. That performs element by element multiplication. Use the dot operator instead. All right. So here I'll stop for a minute. Does anyone have any doubt?
Does the dot operation consider when two arrays don't have matching size, like where the rows and column size doesn't match?
Yeah, it does. So for example, let me try. Let me just take another array. Let me see. And now let's try it again. And it does not aligned. So when you do dot multiplication, it is doing proper array multiplication. So it has to be compatible.
All right, thank you.
Any other doubt?
Sir, can you do for it for a division?
Division,
example.
what we do in terms of division, typically when you do division, you can't really do division as such. What you do is in matrix terms, you do inversion multiplied by the inverse of a matrix. So for example, if I say array 3 divided by array 4, this will do. Now, this is something which is interesting about NumPy versus normal Python, and you'll see why when we see the result of this. Now, when you divide a matrix again, you are doing element by element division just like you did with multiplication, all right? So, but one thing you notice is that because you're dividing by an I matrix, and you can actually see that the error will go away when we do the opposite. This time it won't give you the error. The reason is because when you are dividing by 0 in NumPy, it will not give you a straightaway error, right? With normal Python, if you divide by 0, it will give you a divide by 0 error. You cannot divide by 0. But in NumPy, it will make that infinity, right? Do you see INF? INF means infinity. That means there has been a divide by 0, and it will give you a warning because it will say that you are performing a divide by 0. So it's warning you that you are dividing by 0, but it will not throw an error. But again, if you do a division, it is always element by element. If you want to do a division, what do you call? You want to do a division, the right way to do it is by using the inverse method. So for example, you can use the invert to find out the inverse of a matrix. So for example, let me say array 13. This is the inverse of this matrix. All right. So when you take the inverse, like let me just check if this is inverse. Compute bitwise. Actually, this is not inverse. Sorry. You have to go into the linear algebra. I'll just show you. That is another package. You have to go into the linear algebra, and in here there is the inverse method. This is the actual inverse method. The invert, this invert is not the inverse. This is actually bitwise inversion. This is something totally different. Now this is the inverse. All right. So actually there is something wrong. I think, oh, maybe there is some other problem here, because what is array 3? This doesn't seem right. I'll just check it up, but because this doesn't seem right, let me just see inverse. This does seem like the inverse. There seems to be something wrong. Matrix to be inverted, but this is exactly, so basically what you have to do is, if you want to do proper array division, you have to find out the inverse of the matrix and then multiply it by the array you want to multiply it with. So basically what I'm trying to say is, in array terms, if you want to do A divided by B, this is equal to A inverse multiplied by B. So that can be done using this method. I hope it answers your questions. It is a bit long of an answer.
Yes, sir.
Okay. So I have just a few minutes left. So if anyone has any last doubt or any concluding remark, so please make that now. Otherwise we can wind up this lecture.
The Google Groups thing.
Oh yeah, let me see if we can, because there has been a little bit of a confusion with respect to these webinars. So let me see if it's possible for me to create like a Google group where we can inform everyone of the next webinar. So if that is the case, I will post on LinkedIn maybe a certain email ID, and you can just send me your Gmail ID so that I can add you to a Google group. But other than that, is there anything else?
Is it possible to access old webinar recordings?
Oh yeah, just it's on all of them are on my YouTube. So you can just go, you can just, I think, check out any of my posts on LinkedIn. They will post on, I have posts on my YouTube channel. So all these webinars are added to a playlist. So they are recorded and added to the playlist. So you can access all of them. And this one will be too soon today.
Great, thank you.
Okay, so I just have a couple of minutes left. Any last doubt? Okay, so I guess if there is nothing, then in that case, I'd like to conclude this session. And as before, the recording will be uploaded to the YouTube, to my YouTube channel pretty soon. I'll send the link on LinkedIn, and I'll let you know about the next webinar. But in that webinar, we will probably get started with Matplotlib. So we'll just start plotting some NumPy arrays, and then we'll move on to pandas. So that's it. So for now today, thank you so much for coming, and see you soon. I'll post the link for the next webinar on my LinkedIn or maybe on a Google group, whichever.
Okay, thank you.
Thank you.
Okay, bye-bye everyone.